Hi, this is Denise, and today I'm going to be attempting to explain the electron domain geometries. So I'm going to get into a few key terms and definitions so we have a better understanding. So the shape of a molecule is determined by its bond angles. The angles made by the lines joining the nuclei of the atom in the molecule. The bond angles of a molecule together with the bond lengths define the shape and size of the molecule. So a bonding pair of electrons thus defines a region in which the electrons are most likely to be found. We will call this region the electron domain. A non-bonding pair or a lone pair of electrons defines an electron domain that is located principally on one atom. So not multiple atoms, but one atom. Let's see. Whereas the molecular geometry is the arrangement of the atoms in a molecule or ion. Any non-binding pairs in the molecule are not part of the description of molecular geometry. So we try not to get that confused. So I'm going to go ahead and attempt to use these balloons to make shapes and explain things to you at the same time. So in our first example, I'm going to utilize carbon dioxide. So we know that carbon dioxide is a covalent bond. So in this case, carbon, due to its electronegativity, is going to be in the center. So we're using this red balloon as carbon. And then dioxide, so that means there's going to be two oxygen, making it dioxide on the side of it. So the oxygen atoms will come off of each side of the carbon. So for each oxygen to have an octet, there must be double bonds between the carbon and the oxygen atoms. So in total, there are 2 electron domains, right? And then 2 bonding domains and 0 non-bonding domains. So CO2, carbon dioxide's molecular geometry is linear. And this is because there are no lone pairs in the central atom. So this is going to be our linear molecular geometry, CO2 example. Okay, so next we're going to have nitrogen dioxide. So nitrogen dioxide is going to be right here. So nitrogen dioxide, perfect. So nitrogen dioxide is a covalent compound that is composed of one nitrogen atom at the center with one lone electron. The nitrogen and one oxygen are bonded by a double band, which counts as one electron pair. So in total, there are 3 electron domains with 2 bonding domains and 1 non-bonding domain. So hence the molecule has 3 electron pairs. This is creating a trigonal planar for electron pair geometry. So once again, that is trigonal planar, and once again, this is the nitrogen, and then the 2 oxygen molecules. So I try to pre-do these ahead of time to make it a little bit easier, but I may struggle a little bit later. Okay. So next, we're going to be discussing CH4, which CH4 is methane. I'll get my methane example. So methane. So CH4 methane is a covalent bond, and it is basically made up of 1 carbon and 4 hydrogens. So in this case, the yellow is representing our centered carbon atom. So center carbon atom is the orange atom right here. Oops, sorry, orange right here, right in the center. Perfect. And then we have the 4 hydrogens, which are the black/brownish color, black color, representing the hydrogen molecules. So as I stated, methane is covalent, and the structure that it's creating is tetrahedral, with 4 hydrogen atoms forming around the carbon atom. There are 4 electron domains, 4 bonding domains, and 0 non-bonding domains, creating this beautiful tetrahedral right here. So tetraatom right there. Beautiful. Okay. Next, I'll be discussing SF4, known as sulfur tetrafluoride. So, sulfur tetrafluoride, so this means that there's going to be 1 sulfur as the central atom, let me just go ahead and start making this one real quick because I didn't have time to finish this. So we have one central atom as being the sulfur, and then the other 4 are going to be for the fluoride. So, I mean, sorry, fluorines, not fluoride. Fluorines. Second, so I can give you an example of this. I just like balloons a lot. I don't like the popping noises. At the bottom. I have no idea how the other students did this. Just don't want these to pop at the same time. I'll freak out. Okay, perfect. Awesome. So right here we have our SF4, which is a sulfur tetrafluoride. So in the middle, we can see that the sulfur is the center atom, and it's connected. We see that there's 4 bonding domains and 1 non-bonding domain. So in total, we have the 5 electron domains creating this trigonal bipyramidal. So again, that's trigonal bipyramidal. And so, like I said, you're going to have that one sulfur atom as your central atom being connected by the 4 fluorines, which is represented by the red. See that here? Beautiful. Okay, and then the last but not least, let's see if we can fit these ones in. Okay, so the last one we're going to discuss is the iodine pentafluoride as my example for the octahedral molecular geometry. So in this case, we're going to have our center atom being the purple balloon right here, which consists of iodine. And then I'm going to go ahead and add one more balloon in. One more balloon in to go ahead and finish this up. I hope it will fit. Or I can just put it like this. Okay, beautiful. Okay, awesome. So in this case, we have for the octahedral, we have the center atom being the iodine, right? And then we have the 5 pentafluorides. So this actually should be in the center of this, so it should look something like this actually. Okay, perfect. So this is going to be the center one. So central atom is going to be the iodine, and then we have the 5 fluorines surrounding. 5 fluorines surrounding. Perfect. 1, 2, 3, 4, and then 5 right here on the back of it. You can't see it. Perfect. Okay, so the central atom is iodine with 5 bonding domains and 1 non-bonding domain. This is part of the 6 electron domains, creating this beautiful octahedral. And specifically, this shape for the iodine pentafluoride is known as the square pyramidal. So, awesome. Okay, perfect. All right, thank you so much for watching. I hope I did decent.